linear transformation. Suppose U and V are two vector spaces. U and V are two vector spaces over the same field here. Then the transformation T from U to V is said to be linear transformation if it satisfies the following conditions. First is T of alpha plus beta is equal to T of alpha plus T of beta for all alpha beta belongs to U. Second condition is T of C into alpha, where C is a scalar, C into T of alpha. So all alpha belongs to U and C belongs to the field U. Now let us take an example. Suppose T is defined from E3 of R to V3 of R. So vector space of 3 dimension to vector space of 3 dimension by using the transformation equation T of x1, x2, x3 is equal to 0, x2, x3. Show that T is a linear transformation. So for this, first we consider alpha is equal to x1, x2, x3 and beta is equal to y1, y2 and y3. So all this belongs to V3 of R. Next consider T of alpha plus beta is equal to T of x1, x2, x3 plus y1, y2, y3. Consider this transformation. So this is equal to T of x1 plus y1, x2 plus y2, x3 plus y3. Now this is equal to T of x1 plus y1. So here y1 is 0, x1 in this place. So we can write it as 0. This component is 0, x2 plus y2, comma. So T of x1, x2, x3, y1, y2, y3. By using the given function, we can write it as x1 plus y1, x2 plus y2, and x3, comma, x3 plus y3. And this term will be equal to 0, and this term is x2 plus y2 and x3 plus y3. So T of x1, x2, x3 and T of y1, y2, y3. Therefore, T of alpha plus beta can be written as T of alpha plus T of beta. So the first condition is satisfied, means this condition is satisfied. Next we need to verify this T of C alpha is equal to C into T of alpha. Now we consider T of C alpha. T of C alpha is equal to T of C of x1, x2, x3. So that if you multiply this Cx1, Cx2, Cx3 we get, then T of x1, x2, x3 is equal to 0, x2 and x3. This is from the definition. Therefore T of C alpha, this equation becomes 0, Cx2, Cx3. Now we can write it as C of 0, x2, x3 or C into T of x1, x2, x3. Therefore T of C alpha is equal to C into T alpha. Both the conditions are satisfied, therefore T is a linear transformation. Matrix of linear transformation. Suppose V and W are two vector spaces of dimension m and n respectively over the field A. Then let us consider B1 is equal to alpha 1, alpha 2, etc. alpha m, and B2 2 is equal to beta 1, beta 2, beta 3, etc. beta n. These are the basis of b and w, basis of v and w, test spaces v and w. Then the transformation T from v to w is linear transformation. We know that T can be completely determined by the vectors, completely determined by T of alpha 1, T of alpha 2, etc. T of alpha m. Suppose T of alpha I belongs to W, where I is from 1 to m. Then T of alpha I is a unique linear combination of beta 1, beta 2, etc. beta n. Let us take the linear combination. T of alpha 1 is equal to a11 beta 1, a11 beta 1, a21 beta 2, etc. an1 beta n. Similarly, T of alpha 2 is a21 beta 1, a22 beta 2, a23 beta 3, and so on, etc. alpha an2 beta n. Similarly, T of alpha n can be written as a1m beta 1, a2m beta 2, then anm beta n. Then the matrix of linear transformation is given by a11, a12, etc. a1m, a21, a22, a2m, an1, an2, etc. anm. This is a n cross m matrix. Now let us consider an example. Find a matrix of linear transformation given by T of v2 of r2, v3 of r, such that T of -1 to 1 is equal to -1, 0, 2, and T of 2, 1 is equal to 1 to 1. We need to find the matrix of linear transformation for this. So let us consider T of -1, 1 is equal to -c1 plus c2, and 2, 1 is equal to 2c1. T of 2, 1 is equal to 2c1 plus c2. So this we take as 2 into c1 plus c2. Next, T of -1, 1 is equal to with respect to these elements, we write in this form: T of -c1 plus T of c2. So second element is 0. So T of -c1, T of c2 is equal to -1, 0, 2. Then T of 2c1, T of c2 is equal to 1 to 1. Then we write these two equations: T of T minus into Tc1 plus Tc2 is equal to -1, 0, 2, and this equation we write in here 2Tc1 is equal to 1 to 1. Now we have to solve these two equations. Now if we subtract equation 1 and 2, we get 3 minus 3 into Tc1 is equal to -2 minus 2 minus 1, or T of c1 is equal to this. Similarly, multiply equation 1 by 2 and add with equation 2, so that we get this c1 cancels, we get 3 Tc2 is equal to -1, 2, 5. So Tc2 is equal to -1 by 3, -2 by 3, -5 by 3. Therefore the required linear transformation, the required required matrix transformation is given by AT is equal to 2 by 3. So we write the transpose of this 2 by 3, 2 by 3, minus 1 by 3 and minus 1 by 3, 2 by 3 and 5 by 3. So in this way we find matrix of linear transformation.